All right, so I am on page 758 in your textbook. I want you to turn to that page so that you can follow along with me. Today we're going to be talking about the fundamental counting principle. So right here it says you can use multiplication instead of making a tree diagram to find the number of possible outcomes in a sample space. This is called the fundamental counting principle. In example 1, it says find the total number of outcomes when a coin is tossed and a number cube is rolled. So if we look at our tree diagram, which we're used to making, for our coin we have two options, heads or tails. Now if I flip that coin and land on heads, I still have 6 options for my number cube. 1, 2, 3, 4, 5, and 6. Now if on the first time when I flip my coin, I landed on tails, I still have 6 options on my number cube. 1, 2, 3, 4, 5, and 6. Therefore, my total sample space would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options. Okay? The fundamental counting principle says that we can use multiplication. So if we think about it as in our 2 options, this is my coin and this is my dice. I have 2 options on a coin, heads or tails. Therefore, the total possible choices are 2. On my dice, I have 6, 1 through 6. Therefore, 2 times 6 is 12, which is how many I got when I made my tree diagram. I want you to pause this video and try Got It A on your own. Okay, so Got It A says find the total number of outcomes when choosing from a bike helmets that come in 3 colors and 2 styles. Okay, so if we think about our helmet, we have color options and we have style options. Okay, we have 3 colors, therefore there's 3 different options there, and we have 2 different styles. 3 times 2 is 6, therefore there are 6 total outcomes. This question isn't asking me to list out the outcomes or the sample space, but just asking find the total number of outcomes, therefore I'm done. On the next page, we're looking at example 2. This time we're going to use the fundamental counting principle to find our total number outcomes and then find the probability. So on example 2, it says find the total number of outcomes from rolling a number cube with signs labeled 1 through 6 and choosing a letter from the word numbers. Then find the probability of rolling a 6 and choosing M. Okay, so to find my total number of outcomes, on my dice, I have 6 options, times, on my choosing a letter from the word numbers, if you look at there, I have 1, 2, 3, 4, 5, 6, 7 different letters in the word numbers. Therefore, there's 7 options. So 6 times 7 is 42. Therefore, I have 42 total outcomes. Okay, but it says then find the probability of rolling a 6 and choosing an M. So I can still use fundamental counting principle to figure out my options for choosing a 6 and M. So if I think about my dice, how many options on a dice do you have of rolling a 6? 1 times how many options in the word numbers do you have that is choosing an M? There's only 1. So 1 times 1 is 1. Therefore, to find the probability, I would say that there is a 1 out of 42 chance of rolling an M and choosing the letter M from the word numbers. When you type this in your calculator, you would get a really big number. That's a really small number, but it goes on forever. So we're going to round to the nearest hundredth, so it would be 2 hundredths, which is the same as 2%. So it's not very likely that you would roll a 6 and choose the letter M. Okay, in example 3, find the number of different genes available at the gene shop, then find the probability of randomly selecting a size 32 by 34 slim fit. Is this likely or unlikely that the genes would be chosen? Okay, to find our total number of options, right here you can see we have waist size to choose from, we have the length to choose from, and we also have a style to choose from. Okay, we have 1, 2, 3, 4, 5 different waist sizes times we have 3 different length sizes times we have 3 different styles. Therefore, 5 times 3 is 15, times 3 is 45. So we have 45 total outcomes. Okay, but then we have to find the probability of randomly selecting a 32 by 34 slim fit. So now I'm very specific. So for my waist size, I only have one option, 32. Times, for length, I only have one option, 34. For style, I only have one option because it's slim fit. Therefore, there's 1 times 1 times 1 is 1. So the probability of randomly selecting a 32 by 34 slim fit is 1 out of 45 total options. I can then type in my calculator, 1 divided by 45, and I get a repeating decimal when rounded to the nearest hundredth. It would again be 2 hundredths, which is the same as 2%. Okay? So then it asks, is it likely or unlikely that the genes would be chosen? And we would say it is unlikely. Okay, I want you to pause this video and try Got It B. Got it B. 2 number cubes are rolled. Remember again, these number cubes, we're just calling them dice. What is the probability that the sum of the numbers on the number cubes is 12? How likely is the sum would be 12? Okay, well, first of all, we have to think of what options we have on a dice that we could add together to get 12, because it says sum, and sum means addition, okay? So on dice number 1 and dice number 2, we only have one option on each, because the only way that we can add numbers on a dice and get the sum of 12 is if we take 6 plus 6. There's only one option on a dice that is a 6, and there's only one option on the second dice that is a 6. Therefore, 1 times 1 is 1. Okay, so now we have to figure out the total number of options that we have. On our dice, number 1, we still have 6 total options of rolling, times our dice number 2, we still have 6 total options of rolling. Therefore, 6 times 6 is 36. So we have 36 total outcomes when rolling 2 dice. Therefore, the probability of rolling a sum of 12 is 1 out of 36. Therefore, when I type it into my calculator and I round to the nearest hundredth, I get 3 hundredths, which is the same as 3%. All right, and I believe I have one more example for you on the next page. All right, so example 4. A box of toy cars contains blue, orange, yellow, red, and black cars. A separate box contains a male and female action figure. What is the probability of randomly choosing an orange car and a female action figure? Is it likely or unlikely that this combination is chosen? So we have to think about what we have to select from. So we have colors on our card to choose from. And we also have the action figure to choose from. So I have 1, 2, 3, 4, 5 different colors to choose from. And I have male or female action figure. So 2 different options for your action figure. Therefore, I have 10 total outcomes. But I need to find the probability of randomly choosing an orange and a female action figure. Therefore, for the colors, now I only have 1 option, times, for the action figure, I still only have 1 option because it has to be female. Therefore, 1 times 1 is 1. So I have 1 option that is orange and female. Therefore, the probability of choosing an orange car and female action figure is 1 out of 10, which is the same as 1/10, which is the same as 10%. Now my final question is it likely or unlikely? Since 10% is less than 50%, we would say it's unlikely. Okay? All right, your job is to now do on the same page, number 1 through 4, and then stand up to get your answers checked.